Hey guys, welcome to my sixth or maybe fifth video on A-level physics P5. And whether it's fifth or sixth depends on if I decide the video I previously did was good enough to make the cut. So over here we have this scenario of light, probably white light, that is incident on the front of a photocell. And because of that, an EMF is generated. And remember, this will have to do with conservation of energy, because that EMF is a manifestation of energy, and that energy would have initially come from the light, or would have been carried by the light. So what a student wants to do is he or she wants to investigate the effect of adding various thicknesses of glass in front of a photocell, right? And this may be carried out in a laboratory by varying the number of identical thin glass sheets between a light source and the front of a photocell. That is a feasible method of varying the thickness easily. And the suggestion is that there is a relationship between the EMF V and the number n of glass sheets, and that is V is equal to V naught e to the power alpha nt, right? So what is V naught and what is T? T is the thickness of one sheet, n is the number of sheets, and V naught is the EMF when n is equal to 0, when there isn't any sort of A obstruction. What you have to do is design an experiment to determine the absorption coefficient, that is the alpha, right over here. And you need to draw a diagram to show your equipment arrangement, and you ought to pay attention to all of this. So number one, variable identification. What is the independent variable? That is going to be small n, that is the number of glass sheets, and the dependent variable is then going to be V, that is the EMF generated. And what is going to be the control variable? Stuff that needs to be the same, well, there is V, which is the EMF generated without any sort of a hindrance, right? And obviously there are going to be other stuff, such as the intensity of the light that is coming from the source of light, right? And how do you make sure that the intensity is the same each time? You do that by ensuring that the power is the same each time, and for that you can have an ammeter and a voltmeter, as well as a rheostat, and you can change the value of the rheostat to ensure that the ammeter reading and the voltmeter reading are more or less the same throughout, so the intensity can be assumed to be the same. And to see if the intensity reaching the photocell is the same, you can have some sort of an intensity meter, like a light dependent resistor positioned at a set distance for each repeat of the experiment, to see whether or not the intensity is the same each time. And another thing that can be important is the angle at which the light is incident. You have to ensure that they are at 90 degrees, and for you to do that you have to see that the source of light and the photocell are at a 90 degree, are at parallel to each other, because that is what's going to ensure that the light coming from it is going to be perpendicular to the photocell. You have to use a glass sheet made of the same material, and you can use a vernier caliper each time to measure the thickness at various points along the length to ensure that the thickness is the same each time. If it varies, it's going to have an impact. And when you're choosing what material of glass to use, you have to ensure that it is glass with a fairly low density and so a fairly low absorption coefficient, so that you can have a large value of n, and so any readings you get will be more significant. And you can also use a light source which is just a small distance away from the obstruction and the photocell, and that has a big power supply so that the intensity is high. And all of this is to ensure that any result that you get has a low percentage uncertainty. And obviously it is essential that you repeat all of your readings, and obviously we don't want any other source of light, and so we have to carry all of this in either a dark room, probably a dark room, so that the source from the light is the only one that is significant. So you're going to have to vary n, and from that you're going to get the value of V. But how do you do that? To get V, you need a voltmeter that has to be in parallel with the photocell, and you have to show that. You have to show a photocell with a voltmeter attached around it. And for the light source, that could be a small lamp, you have to show an ammeter and a voltmeter and a power supply, and you also have to show an LDR. You necessarily don't have to show the entire circuit of the LDR, but you have to show that there are other stuff involved. Some way of hinting at that anyways. Procedure is obvious. Vary n, see what value of EMF you're getting, and don't take the value just as soon as you get it. Let the apparatus sort of acclimatize, and when the V value is steady, then you have to take it. Use the same photocell each time. That is something you have to keep in constant. And when you get all of these values, how do you treat it? How do you see whether or not the results you have even matter? And these have to be treated with the help of log. So if you take the natural log of this, you're going to get natural log V is equal to natural log V naught minus alpha nt. So this is what you're getting. So because V is what is changing, it's on the y, and x is going to be n. So what is m? M is going to be basically, and that is gradient is going to be minus alpha t. Right? So if you sort of draw log V on the y-axis against n on the x-axis, and you get a straight line which does not go through the origin, because we have log V naught, which is basically c, that is the y-intercept, then whatever relationship that is given is correct. And because what you want to know is the absorption coefficient, and you should know that the absorption coefficient is equal to minus alpha t, and t is basically the thickness of one of them, and you probably already have the value of that. So if you have taken the value of the thickness for all of them at different points, and you take the mean of it, you can use that here in the equation. So to get alpha, you just have to divide the gradient by 2 and take the negative of that value, and you'll get the value of the absorption coefficient. Safety precaution, you're using high intensity light, so you might want to wear dark glasses or ensure that you don't look directly into the photocell. These are stuff you need to pay proper attention to. So this is it. Hopefully you found all of this to be helpful. If you do, please leave your thoughts in the comment section and like and subscribe. And as always, constructive criticism is more than welcome. Thank you.